Okay, everybody, it's Kevin Lockett once again. Today we have a former Columbia professor. So I'm trying to speak more properly this time because usually I'm like, "Hey,
No,
everybody's Kevin."
don't,
Like, no, I want to be
don't do that. No, don't, no,
more
don't do
professional.
no.
We have Mr. Eric Seigel, Professor Eric Seigel, author of the AI Playbook, and he's also the founder of Machine Learning Week. How are you today, sir?
I'm doing great, Kevin. Thanks so much for having me on your show.
Yes. The reason why I asked you on my show today is about artificial intelligence and machine learning because I am a big user of ChatGPT and I just got into Bard, which is now Gemini. But I always thought when I heard artificial intelligence and machine learning, it was two different things. I heard they were similar. So that's why I'm here with you today because I need to find out about the world of artificial intelligence. So, sir, what is artificial intelligence? What is machine learning? Or are they the same thing?
It's a great question. Machine learning is real, and artificial intelligence is a story that's often fictional. Machine learning is very concrete and very clearly useful. Learn from data to predict. So this is how they target companies target marketing, fraud detection, make decisions about credit applications, decide where to drill for oil, which satellite to inspect for potentially running out of battery, which train wheel to inspect for potentially being faulty. On that level of detail, lots of predictions. And generative AI is another way that machine learning is used, but it's always used to predict. In the case of generative AI, it writes by predicting what should the next word be. Okay, technically it's not word, it's token, but it's on that level of detail. So it's written these 2.5 sentences so far. What should the very next word be? Okay, let's write that word and then do it again. If it's rendering a picture, that's another form of generative AI. How should I change this individual pixel on the next iteration? Again, prediction, learning from data to predict. And that's the core technology. If you want to say that it creates something that's, quote, intelligent, knock yourself out. Having taught the AI, the grad level AI course at Columbia University and been in the field for more than 30 years, um, nobody agrees on what AI is. And I think it's a big problem that we use the word intelligence when we're trying to decide what a computer can do. I think it's great for science fiction and philosophy. And I also think maybe anthropology, we're kind of looking at the human race. Are they trying to get computers to be more human like? Well, yeah, in certain ways, sure. But if you're trying to define an engineering goal, which is what you're doing when you're programming a computer or, of course, a robot, any machine, you're trying to build it to do something specific and well defined. If you don't define it well, you can't get it to do it. AI is mostly used as a synonym for machine learning, but almost always, or at least usually, conveys over expectations. It's hype. It's a way, not always, some people just literally mean it synonymously with machine learning, but more often than not, it conveys something that either exists now or should be supposedly coming soon that's probably a little bit less than plausible. So I'm here to, I don't want to be a party pooper on all the AI dreams and the excitement of human like computers. Um, but I also am trying to see if I can get the world to be a little bit more realistic and concrete because we are talking about science and engineering. What do you think?
What do you think most people get? I think it's very interesting description because I just lumped everything together because I'm not a data scientist. I'm a content creator. So I just heard artificial intelligence, artificial intelligence. That's what we hear from on a daily basis. I think when people hear machine learning, they think like, well, that's something that I have no idea what that is. I'll just stick with artificial intelligence. So they stick with the buzzy word. So I'm
Yeah.
kind of glad that you gave this broad definition of both. Now, will it stick? Because people just say AI all the time. So I think there need to be also a bigger campaign of getting machine learning out there. And I think the more often people hear machine learning, they might have a better understanding of what exactly that is.
Well, AI is a term that's proven to stick which is certainly a double-edged, a mixed blessing at best for the field, right? I mean, it's the ultimate in hyperbole to say that a computer is intelligent or could be, when intelligence is nothing but a human concept. So yeah, AI is a brand. It's a very effective brand. And I dare say that the buzzword's not going to go away, and it goes in and out of favor. That's not to say I'm against incredible chatbots or that I don't appreciate them. So I spent 6 years in the natural language processing research group at Columbia when I was getting my PhD before I was a professor there. And I never thought I'd see what these machines are capable of today. It is really amazing that it can interact. I mean, for those people listening that you said you're using these large language models like ChatGPT and you're using them yourself. Everyone should at least try it. You've got to experience what it does. It does give you that illusion of the quote ghost in the machine. It is amazingly, seemingly human-like. It is capable of working with any kind of human turn of phrase across topics, the way we speak in metaphors. So it's really, really quite amazing. But it's only doing that by generating one word at a time, predicting what should the next word be. That is to say that at the core, the main technology here isn't actually designed or optimized for higher order objectives or big goals like being correct or actually knowing the right answer when you would expect a human to. So that's the disconnect, is that it's so seemingly human-like in a way that's uncanny, is truly impressive and potentially valuable for sure for writing first drafts, so long as a human reviews it afterwards. So that's what they say, human in the loop. But you have to hold that amazement in your head at the same time of the realistic understanding that there's a big difference between what these things do and what humans do. And the story, the narrative, that it's an indication that we're moving toward general human level capabilities like the computers in Star Trek in 2001 and pretty much most science fiction movies. There's no evidence for that, right? That's it's easy to take for granted how multifaceted and amazing the human mind is. And when something seems human-like to a certain degree as a computer, and considering our lexicon of sci-fi concepts, because we've all seen the movies, it's very easy to kind of fall. And then of course there's lots of very clever, charismatic talking heads, especially those that are running large companies that stand to benefit from this amazing branding. All that together, and it's very easy to think, okay, the computers are going to be just as capable as a person. It's just a matter of months or decades. I don't think so. I think it's a lot more than decades. I'm not saying it's impossible that a computer could ever sort of match humans in all capabilities, but I do not believe that we're actively headed in that direction. As awesome as technology and science is, it very quickly becomes a philosophical dispute. But I also think there's a practical side to this misunderstanding, because if the world believes, and if business people who are making purchase decisions and planning products and projects are believing that we're actively headed and it's only going to be 15 years or something like that, that goes hand in hand with the notion that it's already whatever 5-7% as capable as a human, and it totally is not. So like, we need to be like, this technology is really amazing, but not that amazing. Like, you got to be able to hold the limit in your head at the same time as the wonderment.
So we don't have to worry about Arnold Schwarzenegger coming from the future and have the machines take over. So we have to worry about that. We're good.
Well, you'd have to ask Arnold.
I'll try to get him next.
I can't speak for Arnold. I've actually never met him, if you would believe it. I imitate him a lot, especially when he's playing a robot. No, yeah. I do. I think that apocalyptic scenarios, people call it, look, I'm not the only one trying to temper the hype here, by any means. It's just that the hype is pretty loud. So others coined the phrase, the term krita-hype, krita-hype, meaning, look, saying this thing is going to be dangerous is just another way to pump up expectations, because heck, if you believe it's going to sort of escalate to human level capabilities in general and beyond, and take on a volition of its own and wipe out humanity, if it's capable of that, it's probably also pretty good at targeting your marketing. So buy my product, right? That's critter hype.
So let's get down to the business. Let's look at what's real right now. You
Yeah,
wrote
yeah.
in your book the Biz ML framework.
Yeah.
What do businesses get wrong when it comes to machine learning?
Yeah, so there's kind of two layers of fog, and what we've been talking about so far right now is the first layer, the general hype, and is it going to become, is it going to be able to take over human roles wholesale? Is it going to become human level? But even if you dispense with that level of hype and you're focused on a practical application, I'm going to target my fraud detection efforts or my marketing or my financial credit risk management or whatever the process that you're going to improve as an organization. And you're going to do it more effectively with the predictions that machine learning delivers. Great. So you've taken the first step in a step towards concrete value. And ultimately, that's the antidote to hype, is to focus on concrete, specific, well-defined, plausible value. But even after you've done that, and certainly that's where we've been as a field of enterprise machine learning, you could call it predictive AI if you want to distinguish it from generative AI, these types of use cases, also called predictive analytics, which is the title of my first book. Even at that point, there's still another huge pitfall, which is that most of these enterprise machine learning projects fail to deploy. So the basic idea is good, the number crunching and technology is sound, but then there's a whole nother step that's been underestimated and not well planned for, which is the actual deployment. And by deployment, I mean integration, launching, operationalization, the use of the predictions to actively change and thereby improve existing operations. If it's a large scale operation, that's where you stand to improve the most, but that's where there's potentially going to be the most resistance to change, because it's a big deal to make a big change to a large scale operation, right? UPS delivering 16 million packages a day. That's one of the main stories that I cover in the book. But then for them to improve that at a century-old company, set in its ways, was a big change management issue. So it turns out that instead of just treating this as number crunching or technology project, you have to treat them as big change management, operations improvement projects. Changing operations is like selling a root canal, right? It's so much more fun and easy to sell sexy AI technology. But heck, at some point, the hype's going to catch up with us. The lack of returns, IBM has recent industry survey results showing that the average returns of enterprise AI projects is lower than the cost of capital. In other words, you would have been better off just taking the funds and investing in a diversified portfolio. And data scientists and surveys that I've been involved conducting say the same story as the executives, which is, hey, we get enlisted to make a predictive model to do the number crunching. So now we have that capacity to predict, but then it doesn't get deployed because the stakeholders get cold feet. And sort of the takeaway is that if you don't get your hands dirty, your feet going to get cold. If you don't get involved in the nitty gritty details of exactly what you're predicting and how those predictions are going to change operations, you're not going to have the capacity to launch and actually capture or realize value. By doing the number crunching, which is the rocket science part, you're learning from data. That's the fun part. That's why I got into it more than 30 years ago, and probably why most data scientists get into the field of machine learning. But by doing that, you're only generating value that's potential. You're not necessarily capturing it unless you actually act on it with that operationalization, that deployment.
Let's look at the human level from it. I'm going to give you two different scenarios. So I'll talk scenario one. Let's say you have a data scientist and they want to do exactly what you're saying, but then we have the business person over here who's the manager who scoffs at this. Oh, that's those geeks over there. There's those nerds. Who cares about numbers? Yeah. What's the best way of bridging that gap when you don't have? I think it's the guy's name is Jack Levis. Is that the guy for UPS, Jack Levis? Is that his name?
Yeah, Jack Levis. Yeah.
Yeah, let's say you don't have a jack lettuce, but you're over here as a data scientist and no, if we need to push our company forward, we have to do this. What's the best way for a data scientist to bridge the gap with a business manager who might not have the same ideas?
Right. I mean, that's the ultimate question. Is there is this abominable divide, right, between biz and tech, between the data scientist and their stakeholder or their client. And that gap does need to be divided. It's both sides' responsibility. But ultimately, like any other project, there needs to be a leader who's following um, a well-honed practice and leadership style that's going to actually make that happen. And if nobody's doing that, you're going to lapse into the endemic, repeated, routine problem, which is that you have a general idea of what the project should accomplish. The data scientists go off on their own, do the number crunching, and then there's just this disconnect. We need to get deep collaboration step by step. So that's what I'm trying to offer with the book. And you mentioned BizML. That's the name I give to the practice playbook paradigm framework, a 6-step practice that's covered by 6 main chapters of the book that goes end to end. The first step is to plan for the last. So it's reverse planning, plan for deployment. And that's the culminating step 6 out of 6, 6 out of 6. So the main takeaway across that project is that you need to have deep collaboration between the biz and tech at every step along the entire life cycle of the project end to end, if you're going to hope that it actually gets approved in an informed way for deployment and that deployment is successful in capturing business value. The business stakeholders need to ramp up on a semi-technical understanding of how these projects work, and so they can get involved and get their hands dirty in that respect. And basically what it comes down to, and this is what data scientists can help with, is for them to understand what's predicted, how well, and what's done about it. So the what's predicted and what's done about it, that defines an enterprise use case. That's the value proposition. Is this transaction much more likely than average to be fraudulent? If so, block the credit card transaction. Is this customer more likely than average to buy? Then spend $2 sending them a brochure. Is this customer more likely than average to cancel their subscription? Then offer them a discount meant to retain them. Is this satellite more likely than average to run out of battery? Then spend the extra resources to investigate that or go visit the satellite in some cases, whatever it is. It's about triaging and prioritizing limited resources in sales, marketing, and any and all kinds of operations. And so that sort of pair, what's predicted and what's done about it, that's the key. And then the third part is how well is it predicted? How good is it? How good is AI? How well does the predictive model perform in its pure predictive capabilities? And what kind of business benefit in terms of performance indicators, profit, ROI, number of customers saved, whatever, number of dollars saved, does it stand to potentially deliver depending on how you actually deploy it? So again, it's just what's predicted, how well, what's done about it. It's not the rocket science part. It's only arithmetic. It's much easier, more interesting, accessible, and relevant than high school algebra. And yet it's out of reach or out of the knowledge of most business stakeholders. This is the new data literacy. This is where we need to ramp up on this basic semi-technical understanding, and then we can bridge that gap. Then we can have that participation, because what we're talking about here is improving business with science. Prediction is the holy grail for improving large-scale operations because they consist of decisions, and each decision is directly informed by the prediction of an outcome pertaining to that particular, whether the customer is going to click, buy, lie, or die, or whatever the project is meant to be doing. So to bridge that gap, we got to get involved in the particulars. I'll say it one more time. If the stakeholders don't get their hands dirty, their feet will get cold.
So scenario 2, and you might have already answered this within this question. So let's say the business side and the tech side are together on this. Like, okay, we both need to know what to do here. We need to go to the boss who's making the decisions, and we need to tell him that we need to do this. But let's say the person in charge, he's one of those gut guys. It's like, no, I got to go by my gut. I don't like numbers. How do you convince the guy? Maybe you already answered this already, but how do you convince the head guy who's anti-numbers? But even though the business and tech are on the same page, how do you convince this person, almost in a simplistic way, we have to do this? Because if not, we might lose customers. We might lose our profits if we don't stay ahead of the competition.
Yeah, I mean, you're kind of asking the ultimate question, which has a lot of levels to it, because it's also just like science versus gut. That's basically, is it data versus gut, right? There are places when it comes to large scale, I'm not talking about making one-off big strategic decisions. I'm talking about 100,000 decisions a day. Which individual to contact, investigate, incarcerate, set up on a date, or medicate. All of the activities that face consumers and other components and elements of business, hundreds of thousands, millions of decisions made a day. Across those vast numbers, when you're trying to sort of eke out and play the numbers more effectively, that's math, that's data driven. If you're sort of doing it by, well, no, I know my customers are people in this demographic because I go for Midwest housewives and this is just gut and you're not going to use any data to refine it. Yeah, I mean, the world's moving away from that. It's just a culture shift. Of course, if somebody's a zealot about the gut, there's only so much you can do. It's almost a religious debate, but you can. I think most people understand that the world's going to select. It's kind of a natural selection thing. If you don't do it, your competition is, and they're going to reap the benefits and get a competitive edge you don't have because they're going to be using resources more effectively. So, I mean, if there's somebody at the top of the organization who doesn't like operating based on data, it's getting pretty unusual today for modern organizations, but that's kind of more of a religious debate. If we want to just keep this as a business and science and technology discussion, there's not much up for debate. There's just about sort of moving things towards a concrete understanding. And so the lack of understanding, though, is often the problem. So, and it's also not, I don't think it's that common for like the CEO of a large organization to say, no, we shouldn't do this. This is a little bit more about improving things tactically in a very significant way, where you could literally be quadrupling the bottom line profit of a marketing effort or what have you, if not more than that. But with that in mind, it's the stakeholders, it's the decision makers, the person who's in charge of the operations meant to be improved by the model's predictions. They're basically the boss in that context. They're the ones who are going to make a final decision about whether and exactly how to deploy a model when it comes to that culminating point in the project. And there is a lack of understanding. It's more about sort of bridging this gap. So, for example, a stakeholder can probably understand that, look, the predictive model that you get from machine learning after processing historical data is not a magic crystal ball, right? It doesn't have extremely high confidence in all cases. We can't expect computers to be clairvoyant any more than we are as humans, as far as knowing for sure who's going to click, buy, lie, or die, for example. But in predicting better than guessing, that turns out to be more than sufficient to deliver a tremendous improvement to the bottom line in many cases. And I think stakeholders are fully capable of understanding that concept, but they need a little more than that. They need to then see, well, what's the concrete, put that in concrete terms, in terms of real numbers. I understand it's predicting better than guessing, but that's kind of abstract. Can you tell me the exact number and how that turns into a change in the ROI of my marketing efforts, or a reduction in risk of my cardholders if I'm approving credit card applications, or the efficiency and effectiveness of my fraud detection process, and whether, how much fraud prevention I'm actually successful, how much that's saving us, that kind of thing. Doing the right math to bridge that gap into putting into not just technical, but clear business terms is often, if not usually, missing from these projects. It's something data scientists are a little bit stuck. I'm a data scientist. We're stuck in seeing the trees for the forest. We love the geeky technology, so we're geeking out too much, right? So that's the adjustment that needs to take place to bridge this gap. We got to get that clarity on just how good it is and what does it mean to measure its goodness.
So, what is the difference between a data scientist and data engineer? Because I thought they were the same, but through my research, they seem they're
Well,
two totally different positions.
yeah, they are, and those types of job titles are constantly changing and such. But basically, the data scientist would be the one that's doing the actual number crunching, who's using the machine learning software and we're talking about machine learning specifically, because there's lots of other. Data science is a pretty broad umbrella term. It's not just machine learning. It could just be counting, like web analytics is like how many new visitors to this page and stuff like that, and sort of slicing and dicing that. A lot of people call themselves a data scientist. But if we're talking about machine learning specifically, which is obviously a more advanced type of technology than all that arithmetic, they're the ones doing the actual number crunching. They're running the machine learning software on the historical data, whereas the data engineer might be helping them get that data together in the first place. And probably a bigger challenge that's going to be faced is when you do get to deployment and you're trying to operationalize that predictive model so that it changes existing operations. It's deciding in real time which ad to serve to this user or whether to approve this credit card transaction based on a prediction of how likely it is to be fraud. That means that the model that was generated offline by the data scientist now needs to be fed the most pertinent, up-to-date data about that individual case on the fly in real time. So that's an engineering challenge involving getting the data pipelines together. That's what data engineers do.
I think if I have this correct, you said we should focus more on the data than the analytics. Am I correct if you saying that, or did I get that wrong?
Yeah, I mean, it's the data stupid is one of those catchphrases. There was the guy running the Clinton, James Carville, the Clinton presidential campaign. It's the economy, stupid, that became the catchphrase as far as like trying to get their candidate elected, and they did. Obviously, Clinton was elected. So then the data scientists usurped that phrase, and they say it's the data stupid, where data trumps the algorithm. So as advanced as this rocket science core number crunching is, what it means to learn from data to predict, which is really cool, right? I mean, the ability to ascertain, to discover patterns and formulas from historical cases, to garner insights and patterns that pertain and apply and pan out over new, unseen, previously unencountered cases in general, means that it's actually learned something real that holds in general, right? That's what it means to learn, at least in a well-defined sense. And that's why it's called machine learning. So that's great, awesome, amazing technology. And the methods, the algorithms, the software that does that can get super advanced. But there's a point where there's diminishing returns on that complexity. And really the thing that makes the difference is better data.
Before we started talking, I was telling you how I had an old audio. When I first started, I had an audio podcast. But one of the guests I had back in my audio days was a woman named Maya Schwerner, and we were talking about data policing. And we were predictability models, and they use zip codes to predict where people will commit certain crimes. And I'm more of a social justice person, so I was like, man, like you can't really say like most of the people in this area is going to be committing the most crimes because you miss people over here. When it comes to your research, machine learning and AI and all these things, how does data police and okay, I'll put it this way: biasness in machine learning and artificial intelligence, is that something that we should be concerned about? Because it's still human beings putting in this information. So how do we avoid being unbiased towards people?
Yeah. I'm super concerned about that type of bias. And it's not just predictive policing is a very poignant example, but it also could be for driving other consequential decisions, such as whether you're approved for a loan or for housing. But the decision about how long you remain in prison, that's obviously a pretty big one not to get wrong, especially when we're talking about getting it systematically wrong more often for one protected group than another. In fact, I devoted an entirety of of chapter 2 of my first book, even the first edition, 2013, to ethics. And I've written a bunch of op-eds related directly to what you just brought up in Scientific American Blog, San Francisco Chronicle, and other places. And if anyone wants to read my op-eds, I put them all together at civilrightsdata.com, and there's a dozen of them there linked. But yeah, I think we need to take on the standardization of responsible machine learning as an act of social justice. And that's what I say in the conclusion of my new book. And what do I mean by that? Well, it's not so much a technical issue as a sociological one. What you actually get from the number crunching is it puts it on the table the way in which historical injustices actually pan out today in unfair ways. And it's not that the model is unfair. It's how you use the model and whether you're complacent. You're like, oh, well, that's just the way of the world. Sorry, life's not fair. I think that's a bad attitude. Whereas there's potential now that we put it on the table and we see those differences in costly errors rates that I just mentioned. So, for example, crime prediction models. You just mentioned predictive policing as far as the geography, like where should we be sending police cars? But another issue is per individual human, along the lines of targeting marketing and credit decisions. Does this incarcerated felon deserve parole? So the prediction in that case is recidivism. So will the convict upon release be caught, convicted, and incarcerated again? That's called recidivism. So that's what they're predicting. And if it's considered a high chance of recidivism, that's a reason that judges and parole boards will count against them. So yes, it's still a manual decision by humans, still partly based on the gut, as far as a decision of judge deciding on a sentencing duration and a parole board deciding on parole. But if the machine is systematically giving these risk levels for each individual for these decisions, obviously, in some cases, the machine will be the deciding factor. Amongst those cases, the machine will be wrong sometimes. The humans are not magic crystal balls and don't have clairvoyance, and neither does the machine. The machine, in some sense, may be less biased than humans and may be better by some measures than humans, but it turns out that we have this horrible side effect of the state of the world today and all the historical injustice that's gotten us here, which is that there's a higher false positive rate for Black male convicts than for white male convicts, for example. And this came out in a ProPublica piece. It's very often cited. It's sort of the main reference for this particular topic, the topic being machine bias and the title of the article being machine bias. And in that case, we're talking specifically about, so a false positive would be when the predictive model in the machine says positive, as in this is a high risk case, but undeservingly. So potentially then a judge or parole board would count it against them. And there are going to be cases where it gets it wrong. The problem is that it gets it wrong in that particular way twice as often for Black convicts than for white convicts, for example, amongst males. So you have these disparities. And if you look at the numbers, it's because it's not because the model uses a protected class like race as a direct input. So it's not literally deciding directly on that, but there's plenty of other proxies, right? History about the individual, the location they live, all these other things are highly correlated with protected classes like race. So as a result, you have this dramatic disparity that I consider injustice. And I think it's terrible and complacent to say, well, because the fact is, they did normalize it in a certain way, in the sense that among all the convicts that it says are 70% chances of being convicted again, recidivism, in fact, it is 70%. So the model is sound in that respect. And if you divide by race and just look at the white ones, 70 means 70, just look at the black ones. 70 means 70. So those defending the model give you that data. But it doesn't change the fact that on the other view, there's a higher rate. If you're a black convict, you have twice the risk of having a false positive than if you're a white one. So what I see here is an opportunity to do something about it, right? Instead of it just sort of being a side effect of humans making decisions from the gut, now that all the data and the results of where we are as in the world is on the table and quantified, and the system that's in place to use the math to drive decisions is also infrastructure that we can leverage. Now we can adjust for it. The problem is that to adjust for it means you have to reintroduce the protected class like race, which means you have to do something like affirmative action. That's why I'm very much for affirmative action. I see these numbers as representing, as being a manifestation of historical injustice and the opportunity to account for it. Unfortunately, affirmative action is not an easy thing to sell, right? There's a lot of disagreement around it. But I think that my main point here is that this is a sociological issue just brought to another level by technology, not a technology issue.
You wrote your book, I believe, Predictive Analytics, in 2013, I believe.
First edition, yeah, updated in 2016.
How has things changed or not changed in that time since you wrote that book?
Well, with regard to the ethics,
Yeah, just everything, just as your book as a whole. I mean, have you seen a great progression since you wrote your book, or have you just see some things just kind of move very slowly?
In general, not just just since we were just talking about ethics, I'll first address the ethics, which is unfortunately, I don't think it's changed too much. I mean, the idea of a false positive is not a part of the common vernacular in general, let alone around ethics. And it needs to be, because those are the costly errors. And those are the unjust, unfair errors, right? And you can do something unfair to anybody of any race. The question is when that rate of unfairness differs across groups, right? And I don't think that the understanding of that, it's not rocket science, but I think it's so core to understanding what it means to be implementing and operating a society that's meant to be just. So I don't think it should be outside of scope, right? Again, it's another one of those things that's so much more simple mathematically and relevant than high school algebra. And yet it's under everyone's radar. So I'd like to see that change. But more generally across the field of machine learning, and now with generative AI is the biggest thing that ever happened with the field of machine learning. The ability for the computer to write first drafts and to draw these images is just unprecedented. And for many contexts, very useful and valuable. So long as you remember that you need to have a human in the loop, you've got to be considering it first drafts. It's not necessarily a step towards autonomy in the sense that the computer is going to take over a human role. There's a reason you don't see these chatbots unleashed as a customer service agent instead of a human, but it could be helping a live chat human agent sort of draft paragraph responses and stuff like that. So, and it's a very, very exciting demo, if nothing else, right? So it really kind of shows you what you can get from learning from data in terms of sort of a visible, cool, impressive effect. I mean, I think, and it really has brought a lot of people's attention to this kind of technology. At the same time, though, the types of predictive applications that I'm talking about and that I've been focusing, and that the industry's been mostly focusing on for decades now, those haven't gone anywhere. And that's still where most of the resources are, the proven results. That's where the money is. More of the investments are. And that's the kind of technology you turn to if you want to improve an existing large scale operation. So it's kind of apples and oranges, this sort of all the spotlight and public attention on generative and its potential versus predictive. They're built on the same core technology, but they're sort of becoming two distinct fields in a way, even though they fall under the so-called AI umbrella.
Just doing a sidebar for a second, going back to ethics and bias. I really
Yeah.
thought in around 2021, when we had the pandemic and we had George Floyd, that we were going to move in a different direction. From a George Floyd standpoint, I figured, okay, when we're going to make a turn, when we make things more, we have more understanding when it comes to racial bias and things like that. And then for the pandemic, I saw like remote work and people enjoying remote work and working from having a different model when it comes to working. But it seems like in all cases, we kind of reverted back to we were before. And actually, in some ways, I feel like we're going backwards. Even with the new technologies pushing us forward, it just seems like we're good. Technology-wise, I feel like we're going forward, but in a lot of ways, just as a human beings and concerned about people, I think we're going backwards.
Yeah, I mean, it's a dark time for a Democrat or a liberal. Nothing to laugh at. Although that's why I like the comedians. They take the edge off, maybe. But yeah, I don't know. I mean, I think that machine learning is a tool, right? And tools in general tend to be good. Like nobody's talking about outlawing knives, even though they obviously can do terrible harm. How am I going to cut my cantaloupe, right? And making the world operate more efficiently and effectively tends to be a win-win in general, right? But it's it's amoral, just like any kind of technology, right? It depends on how you use it. So I've always been a technologist. I started programming computers when I was 10. Just because I thought it was cool and it seemed powerful. And so it's interesting to see all the ways that it can be, used to benefit organizations and thereby often benefiting consumers. But that's Spider-Man's uncle. With great power comes great responsibility. So we can't lose our humanity. And there's this, that's part of the narrative. Is it's sort of like the machine in the narrative, in the story, in the fantasy, in the AI storybook, right? The book that Mary Shelley, who wrote Frankenstein, would have written if she knew about algorithms. We transcend humanity and also dispense with it, maybe, because transcending it means maybe it's irrelevant and the machine's going to supersede it. And it's a fantasy, but to the degree that fantasy entices people, may also be the degree to which people think technology trumps humanity in all different ways. But it doesn't. It's a tool for us, right? We're the people. We the people, right? We're doing this stuff and we're using these tools, and they're not using us, except for in science fiction. I like science fiction. I like suspending my disbelief. But if we're not operating in the realm of fiction, then don't suspend your disbelief. Don't believe the hype.
Yeah. Don't believe the hype, as PE once said. So you mentioned comedians, you mentioned Uncle Ben, Peter Parker's slain uncle. What do you, when you're not being a data scientist, what do you do for fun? How do you relax your technical brain when you're away from these things?
Relax? How do I relax? That's a crazy question.
Basically, yeah. Like, I know you're in the data all the time and researching all that stuff, but you have a life. Like, what else do you do when you're not focused on data?
Until a few years ago, my favorite thing was movies by far. And I love it in a movie theater. I miss that. I don't have time these days. But that, as my favorite thing, ended because I now have two toddlers who are 3 and 1 year old, and that's my passion. Right. And I'm a very happy. I might not be the youngest dad in the world, but I'm probably the happiest one.
You should put that on a card. That's nice. So before you became a loving father, what's your top? I know it's hard to say this. What's your top 5 movies? What movies could you see over and over again? If let's say the toddlers had a play date, and you could watch any movies that you want. What movies would you watch?
Oh, I mean, I became a movie snob. I didn't mean to. I'm not a music snob. I love the Bee Gees. It's like I grew up on this Bee Gees and it never wore off. And it took me a long time to admit that publicly. But with movies, I became unwittingly a total snob. I can't watch superhero movies anymore. I grew out of it a long time ago. So, like, what's the last thread? The last of the Mohicans. What's his name? Daniel Day-Lewis. His Swan Song movie. These art house movies that really deliver human messages and get in and just present a beautiful portrait, even if it's of a very ugly thing. Those are the movies. Now, I don't an entire snob. I do like some mainstream movies. And if you want to talk sci-fi, I loved Ex Machina. All those kind of AI movies, if they're really good, like the movie Her, I don't consider that an AI movie. I consider it a whimsical, fantastical fantasy about love. To the degree you think it actually represents what technology really could be headed towards right now, I think that's a little silly. It shouldn't be taken that literally. But as a piece of work, it's great. So those are the kinds of movies I like. And I didn't mean to. I used to like the big action movies, and now I'm just like. Now, having said that, the latest Mission Impossible was so over the top. And at this point, even a good action movie, I almost always hate the third act. I'm just like, oh, just fast forward it. It's so contrived, and it's always it just loses me. This was an exception. The latest Mission Impossible, I was just that whole final act. I was like, wow, this is working. I'm actually tense. I care. The train keeps falling off the edge. And so I was like, how did they do that and not burn me out like I usually do? So kudos to those guys.
Kudos to those guys. Because I'm a movie guy too. Joaquin Phoenix won the Oscar for Joker, and I love Joker, but he was excellent in Her. I don't think a lot of people realize how good Her was with him and Scarlett Johansson. And Ex Machina with Isaac Isaacs was amazing. Yeah. It's almost like I wish there was actually maybe it was great how they ended it, but I really wish there was a sequel because I'm actually interested how it moved forward at the end because the whole movie to me was like shocking. It's like, oh my God, this is really an intense film. What's going into it? I didn't think it was going to be that intense.
Yeah, I saw that movie in a really small theater in LA, and the director, what's his name again? The director walked in right before it started, picked up a mic and said, "Hey, welcome to my movie," introduced himself, and everyone started clapping. There was like 12 of us in the theater. And he's like, "Oh, you haven't seen the movie yet? Don't clap yet." And it was just like, I guess I'm in LA because that doesn't happen anywhere else,
Right. Are you based in LA or you're not?
No, I was in LA for 3 years a while ago, but no, I'm back in the San Francisco area.
Okay, that's cool. That's nice. So what are some of the emerging trends when it comes to machine learning? What type of things should we be looking out for?
So I think that the biggest trend is the whole generative AI thing. And that's built on neural networks. Before that, the big trend was deep learning. And so basically, as I mentioned, with predictive applications, you often don't benefit in a way that's worthwhile to get when you get very complex in terms of the core technology. There's diminishing returns, and the additional complexity is sometimes just not worth it. But depends on the application. So if you're trying to detect, is there a traffic light in this picture? You can always get better in that, and that'll be critical as some driving autonomy or driver assistance stuff continues to develop. So then you do want to start getting more complex. And the leading technical method there is called deep learning. Now they took deep learning and they amped it up even more. They made these networks, which are basically just it's a network people compare it to the human brain, but that's very that's a very questionable comparison. I mean, it's sort of more of an analogy, but the fact is it's a way to build up a very complex mathematical formula from a lot of simple components, and you put them all together like building blocks, and it's a network, fine. But the main point is that they've been able to get the thing to scale so that it takes lots of inputs and can learn from a lot of examples. So for example, you might have 10 million, 100 million pictures that do and don't have traffic lights, and it's trying to tell the difference. And now you apply that to the human language, and that's where you get these language models like ChatGPT. And you've got a lot of data to learn from, because every time if you take any web page and you've got a few paragraphs, and then you just arbitrarily cut it off halfway, for example, and then you have a prediction goal, what should the next word be? You've got a learning example there because you know what the next word actually was. And then you put that word on, what's the next word supposed to be? Yet you have yet another learning example. That's why there's trillions and trillions of learning examples that are just sort of intrinsically sitting there on the web. And that's what they've been leveraging in combination with amping up the core learning algorithms themselves and with deep learning. And that's the basis for large language models.
What's the difference between living in San Francisco versus living in LA?
Yeah. So I escaped from San Francisco 2 years ago. We moved up here to Marin, which is just 45 minutes north of the city. Before then, I was always living in big cities ever since college. I graduated college in 91, so I was in New York, LA, San Francisco, and Rio. Not in that order, mostly San Francisco. So now, but having spent 3 years in LA, now I know what everybody means when they make fun of, oh, it's so LA. Now I know what that actually means, because I never understood it's the stigma or that kind of giving crap to the city. I was like, is that really well founded? But now I know. So here's my take on it. When you're talking to somebody in LA, they're not literally looking over your shoulder for someone more important. Not literally. But the elephant that's usually in the room is that everybody has these grand ambitions. In a way that's largely positive. It's kind of cool. Everyone's got 5 projects. They're writing a book. They have a podcast. They've got a script, etc. They've got a whole bunch of projects. It's so much creative energy, and it's so interesting. But the ambition is sitting there. So when does it become kind of a casual chat without this feeling like really every breath is about the ambition? And that's the feeling about the culture. Now, having been in San Francisco on and off since 2003, I think that it has the same thing now, especially if you go south of the city. But it's a completely different, it's about your technology career rather than your entertainment career. So they're two very, very different flavors and colors of sort of the same human condition, but they have a completely different feeling. But they're also both a little overbearing, so that's why we moved north instead of south.
Well, Eric Seigel, thank you for the conversation. If people want to check out AI Playbook, where can they go? And why should they pick up AI Playbook?
Go to BizML. So that's the name of the 6-step playbook, titular playbook of the book. BizML, the business practice for running machine learning projects, bizml.com. That'll be the website for the book. And the book, along with covering those steps to run a project so it actually succeeds, does the ramp up, right? It provides the reader that semi-technical understanding along the way, as well. It covers those 6 steps through a bunch of examples, UPS, FICO, some prominent .coms, in a way that's very anecdotally driven and accessible. The book just came out last week, but my first book was a bestseller, has been adopted at hundreds of universities. And I think for the reason that I tried to recreate with this book, which is that it's super accessible, it makes it concrete. It's not just about hype or high level buzzwords. but it makes it very specific. You look under the hood, you get a sense concretely of how it works and how it delivers value.
And my final question, what is your favorite Bee Gees song?
Oh, How Deep Is Your Love? Obviously.
Ooh. I like that's a beautiful song. I am always torn between Nights on Broadway and Love Inside Out.
I don't know what Love Inside Out is.
I like all those songs. Oh, it's fantastic. Those songs are fantastic. It pained me when people started hating the Bee Gees. I was like, why? They're so good. They're so good.
I know. Things get stigmatized and they get too popular, right?
Yeah, right. Thanks a lot, Eric.
Great talking to you, Kevin. Thanks for having me on.